What if I told you that one of the most powerful tools in all of digital security isn't some super complex algorithm, but just a simple list? It's this incredible idea that's been protecting our data for more than half a century, and today we're going to break down exactly how it works. This is all about access control lists, or ACLs.
When you boil it all down, security really just comes down to this one simple question, right? Who gets in and who doesn't? Doesn't matter if it's a top secret government file, your company's private network, or even just your own photos. Something somewhere has to decide who's allowed in and who gets turned away at the door.
And believe it or not, it often comes down to something that sounds almost too simple. It really is like a bouncer at a club, standing there with a clipboard. It's a list, and that list determines who gets in and, just as important, what they're allowed to do once they're inside. Okay, so let's get right into it. What exactly is this list? Well, it's called an access control list, or ACL for short. And honestly, it's the bedrock of how so many systems manage permissions. So here's the textbook definition. An ACL is basically a list of permissions that's attached to a specific thing, like a file. That list spells out exactly which users get access and, this is the crucial part, what they can actually do with it. So it's not just about getting past the door, it's about what you're allowed to touch once you're in the room. And this right here makes the whole concept super clear. Just imagine a file with this little list attached to it. Alice, she's on the list. She can both read and write to the file. Bob, he's on the list too, but he can only read it. And poor Carol? Well, she's not on the list at all, so access is completely denied. It's such a simple idea, but in practice, it is incredibly powerful. All right, let's look at the first major place you'll find these things in the wild, right there on your computer, managing all your files. This is actually where the whole idea got its start. So you can think of a file system ACL as this tiny, super detailed rulebook for every single thing on your system. Every file, every program. And each individual rule in that book, that's called an access control entry, or an ACE. You string a bunch of those ACEs together, and boom, you've got your ACL, defining exactly who can do what. And get this idea has been around for a long, long time. The very first version showed up way back in 1965 with an old operating system called Multics. Then in the 90s, there was this attempt to standardize them with something called POSIX, but that kind of fizzled out. Today, the modern standard that you'll see pretty much everywhere is called NFSv4 ACLs. So why does this NFS4 thing matter? Well, for starters, it's a real published standard, and it's way more powerful than the old versions. It lets you get super specific, or granular, with permissions. Plus, it's supported by modern systems like Solaris and macOS, and, this is a big one, it's built a lot like the ACLs that Windows uses, which makes it way easier for different systems to talk to each other and share files securely. Okay, so we've seen how ACLs protect individual files. Now let's zoom out and see how this same idea scales up to protect entire networks. Turns out that same simple list concept is absolutely perfect for controlling the flow of digital traffic. So in this scenario, our bouncer isn't guarding a file anymore. It's a router or a switch. And the folks trying to get in, they're data packets flying across the internet. The ACL is what tells the router which packets get a pass and which ones get dropped, all based on stuff like their IP address or their port number. The whole process is incredibly fast and simple. A packet shows up, the router glances at its address info, it checks that info against its ACL, its rulebook, and based on the very first rule it matches, it either forwards the packet along or just drops it right there. This happens millions of times every single second. Now, if that whole process of checking and filtering traffic sounds a little familiar, well, it should. A network ACL that's controlling the data coming in and going out is, for all intents and purposes, a firewall. It's one of the most fundamental building blocks of all of network security. So you might be thinking an idea from 1965 has got to be obsolete by now, right? Wrong. ACLs are actually more relevant today than ever. They've been adapted and completely reimagined for all kinds of modern systems. I mean, the concept is everywhere. In Microsoft's Active Directory, ACLs get so ridiculously detailed they can control access to a single piece of a user's information. They're used deep inside complex SQL databases, and brand new versions are still being invented, like Schema-indexed ACLs, which is a super lightweight model designed just for modern web tech like tokens and cookies. The core idea is just constantly being adapted. Now, to really understand ACLs,
It helps a lot to know about the main alternative out there, a model called role-based access control, or RBAC.
So both of these models are trying to achieve the same goal, but they come at the problem from completely different angles. And really, the difference is all about focus. Okay, here's the key difference. An ACL always focuses on the resource. You start with the file, you look at its list, and that tells you who can get in. RBAC, on the other hand, flips that around and focuses on the user. You give a user a role, like editor or admin, and that role comes with a whole bundle of predefined permissions for a bunch of different resources.
But what's really interesting is that while they started out as these two different philosophies, the lines have gotten really blurry. Modern ACL systems can handle groups, even hierarchies of groups, which makes them powerful enough to do basically everything an RBAC system can. They've become just incredibly flexible. And that brings us right back to where we started, the access control list. It's just a testament to a simple, powerful idea. We're talking about a concept from the old mainframe era that has evolved to secure everything, from our files to our networks to the cookies in our web browsers. It really makes you wonder, doesn't it? What will the digital gatekeepers of the next 60 years look like?